Bismillahirrahmanirrahim. My name is Mohsen Khan, and as I discussed in my previous video, so today we will further proceed, and today my topic is mineral causing alkali aggregate reaction. In some aggregate there are some minerals which cause deleterious effect, which cause expansion in the concrete, and ultimately it will destroy the durability of the concrete. So there are a few minerals I will just mention here. The first one is the silica. This is the most strong material, and sometimes if it is strained, intensively fractured, and microcrystalline quartz, so we have to find it out during the petrographic analysis. And if this one is present, then of course this is reactive material and we need further testing. There is another variety, that is opal, and this is a hydrous form of silica. Their properties a bit inferior as compared to the silica. The water content is mostly 3 to 9%, and specific gravity and hardness always less than quartz, or you can say from pure silica. If you will go for the sedimentary rock example, so mostly you will find this one in the chert. In the rock there are some we can say nodular limestone, so there are these chert particles are there. If you will go for the sometime volcanic rocks, so as in volcanic, you can say igneous rocks, so the secondary deposits you can find it there, sometime in the form of coating for some aggregates or for some sands. So these things you can, so mostly you will find it there. And as a filling cavities and fissures, it also deleterious, need to be recognized, and as it react with alkalis from the ground mass, from groundwater, and it will cause also some deleterious effect. The third one is chalcedony. This is again a form of silica, and this is the properties for this one is in between the opal and the pure silica. So we must identify these things, that which type of material is there, whether this one is deleterious or not. The other one is cristobalite, or you can say tridymite. So tridymite, this is also high temperature crystalline form of silica in volcanic rock. The main problem with this material that it is metastable, and normal temperature and pressure it is not stable. It's going to do a reaction which ultimately cause problem with the concrete. The third thing, the other thing is you can say the clay material, and mostly this smectite. If smectite is there, so what's going to do with your concrete, because it's sensitive for wetting and drying condition. So if it will get wet, so the volume will going to increase, and on the time when the drying period will come, so all the water will come out and it will shrink and it will reduce the size. So these things are not feasible for concrete, and we want to avoid this one, because ultimately it will crack the concrete and it will create a problem. The other material, which is zeolite, this is secondary fillings in vein and fissures. It is also deleterious as it releases alkali in the concrete, so again not feasible. Some other material are sulfate minerals and basalt, which release alkali. So these are some material which we must identify during the petrographic analysis, because if we will go for this one and we need the percentage for this one, so clearly we have to identify this one. If this material is there, then further testing is required. If not, then safely the petrographer, he can say that further investigation is not required, as these deleterious materials are not there. So thank you.